This is the Federal Emergency Management Agency's, or FEMA's, flood map for the study area of East Boston. These maps are used to determine flood insurance across the country, and many were completed using a number of different computation models by both FEMA and independent engineers. Since the devastation of storms such as Hurricanes Harvey and Irma and the bomb cyclone in Boston, FEMA has received a lot of criticism for its map-making process, such as having a backwards-looking methodology based on historic floods and not having maps of projected future conditions that consider climate change. We decided to focus on East Boston between the East Boston Greenway to the former Suffolk Downs site. This area has recently gained a lot of press for the new Amazon HQ2 location, spurring questions about gentrification, displacement, and climate vulnerability. We evaluated 3 models that tell 3 different stories for the area's future and developed a website for others to explore these discrepancies.
The first model, called Sea Change Boston by Sasaki Associates, made in 2014, paints an alarming picture. Sasaki used topographic information and estimated flood heights to create a bathtub model, raising the waterline to the estimated flood levels. This is a straightforward method, but doesn't take land use, surface roughness, wind speed, or storm idiosyncrasies into account. Climate Ready Boston, a more recent municipal effort to plan for the city's future given climate change projections, uses a more robust model which takes into account wave action to estimate flood depth and probability for 2020, 2030, 2050, and 2070. While the model results vary due to differing methodologies, margins of error, and probabilities, they represent drastic differences in how people prepare for and understand extreme storms. This map displays the modeled cost of damage between each of the models and the difference between them. As you can see, rounding errors in the models result in millions of dollars and many buildings being damaged in East Boston alone.
The differences between the models are not surprising when you consider each organization's methodology and audience. But the information necessary to interpret and rectify the different models is not commonly available, which is why we propose more transparency and consistency in producing these maps. We believe this can be accomplished by making the process by which communities can update their own maps easier. Specifically, we advocate for releasing a standard, open-source tool that communities without technical expertise could use to estimate their own flood risk and evaluate FEMA's current maps. We also advocate for more flood preparedness funding so that FEMA can update the maps for areas of the country left out of this process. Furthermore, we propose that FEMA release both short-term and long-term flood projections to allow FEMA to take climate change into account without the political implications of immediately requiring many more households to buy flood insurance. Finally, we believe that FEMA should release more metadata for its maps, including the revision history of the map area, who initiated each revision process, what model was used, and what was the effect of the revisions. This would allow both the public and technical experts to better interpret how the politics behind the model affect its output.